How big is the universe? Right now, as you read this, you're standing on a rock spinning through space at over 1,000 kilometers an hour. It feels still. It feels like the whole world. But the truth is, Earth is barely a grain of sand in something so vast that our minds were never built to hold it. So let's try anyway. Let's start small and zoom out further than you've probably ever imagined until the numbers stop making sense. Stop 1. The Moon. Just 384,400 kilometers away, close enough that if you drove there at highway speed, a constant 100 kilometers an hour, it would still take you over 5 months without stopping. Light, the fastest thing in existence, covers that same distance in about 1.3 seconds. That's the whole moon, done in the time it takes to blink. And already, this is nothing.
Stop 2. The Sun. 1 astronomical unit away, about 150 million kilometers. Light takes roughly 8 minutes and 20 seconds to make that trip. Fly there in a commercial jet, and you'd be traveling for close to 20 years. 20 years just to reach our own star. And the Sun isn't even a large star. It's average, unremarkable by cosmic standards. That should already feel strange. Stop 3, the edge of our solar system. Neptune sits about 4.5 billion kilometers out. Sunlight takes over 4 hours to reach it. If you tried flying there by plane, you'd be airborne for nearly 500 years, longer than the United States has existed. And even past Neptune, we're still not done. There's the Oort cloud, a theoretical shell of icy debris stretching perhaps 100,000 astronomical units from the sun, almost 2 light years deep. That is the true edge of our solar system. And it's just the beginning of the beginning. Stop 4, the nearest star.
Leave the sun's influence entirely, cross into interstellar space, and the next star system, Alpha Centauri, is about 4.4 light years away. That's roughly 41 trillion kilometers. Our fastest spacecraft, moving at 17 kilometers per second, would need over 70,000 years to get there. 70,000 years for the closest star to us. Every other star in the sky is farther still.
The Milky Way spans about 100,000 light-years across, home to hundreds of billions of stars, each one a potential sun to its own planets. Somewhere in the middle of all that, human radio and television signals have been leaking into space for about a century, forming a bubble roughly 100 light-years wide. That sounds like a lot until you realize it's a pinprick against the galaxy's full size. Beyond that bubble, it's as if humanity never existed. No signal has reached that far. No one out there knows we're here.
To really feel this, try compressing the entire Milky Way down to the size of Earth, 12,742 kilometers across. At that scale, our sun would shrink to smaller than a grain of dust, and Alpha Centauri, our nearest neighboring star, would still sit over half a kilometer away. The galaxy isn't just big, it's big in a way that mocks the word big.
Stop 6. Beyond the galaxy. The Milky Way isn't alone. It belongs to the Local Group, a cluster of more than 50 galaxies, including our neighbor Andromeda, spread across roughly 10 million light-years across. Light itself would need 10 million years to cross from one edge of this group to the other. And the Local Group is just a small suburb inside something far larger, the Virgo supercluster, about 110 million light-years across, containing thousands of galaxies bundled into at least 100 galaxy groups and clusters. Zoom out again, and even the Virgo supercluster becomes a small piece of the Laniakea supercluster, a structure over 500 million light-years wide, containing the mass of roughly 100 million billion suns. At the heart of Laniakea lies a mysterious region called the Great Attractor, quietly pulling entire galaxies toward it through gravity we still don't fully understand. Our galaxy, our sun, our Earth, all of it drifting towards something we can't even properly explain. Stop 7. The observable universe. This is where it gets almost impossible to comprehend. The observable universe stretches about 93 billion light-years in diameter. And here's the part that breaks people's intuition. The universe itself is only 13.8 billion years old. So how can it be 93 billion light-years across?
The answer is that space itself has been expanding since the Big Bang, stretching the distances between galaxies even as their light travels toward us. Some regions are expanding away from us faster than light itself, which means their light will never reach us, not in a million years, not ever. Those galaxies exist somewhere right now, and we are permanently cut off from ever seeing them. Which raises the question nobody can answer. What lies beyond the observable universe? Is it more galaxies stretching forever? Is it something entirely different? The truth is, we don't know, and we may never know. The observable universe, as staggeringly large as it is, might be nothing more than a tiny fragment of a whole that has no measurable edge at all. So, how big is the universe really?
Here's the honest answer. We don't know if it even has a size. It might be infinite. It might loop back on itself. It might contain regions so distant that light will never bridge the gap between us and them, no matter how long we wait. What we do know is this. Within that possibly infinite expanse, there are an estimated 2 trillion galaxies, each containing hundreds of billions of stars, each star a candidate for its own planets, its own possibilities, its own untold stories. And somewhere in all of that, on one unremarkable planet, orbiting one unremarkable star, in one arm of one ordinary galaxy, you exist. Reading this, thinking about numbers too large to hold in your head, that too is part of the story of how big the universe really is.